Hello, everyone. Welcome to our live session. My name is Precious Piri. I'm talking to you from Zimbabwe in the beautiful town of Victoria Falls. I bring you social distance greetings and hoping that you and all your families are well. I'm here with two gentlemen. One, Mr. Dakishoni Laifolo from Malawi, who works with soils and food for healthy communities. There he is, he's waving. And then the other person is Mr. Roland Bunch, who's based in California. He's the Green Manure Man, and he needs not a lot of introduction, and we have a lot of his work. I'm sure most of you are aware of him, but I will also just give him some time. I'll give both the gentlemen some time to just say hello. Today we're just here bringing you a bit of a hopeful program, really, given the unprecedented times that we have faced during the COVID-19. We're coming to talk about the use of green manure or cover crops, which are used to really improve our soils and crop fields, and to help communities really be resilient and thrive in the areas of food security. And Roland has had lots of experience with this work. He has also incidentally worked with Dakishoni and their organization in Malawi. They have implemented these on the ground. So we have a broader perspective that we'll get from Roland, and then we'll also get a perspective of actual on the ground, everyday communal work with Dakishoni. One of my hopes is that after this, we'll be able to really just tap into the wisdom that these communities are using, and also maybe as a global community, since most of us are from different places, find a way of linking up with Dak or Roland. How can we support and spread and scale up this work? Again, my name is Precious Piri from Regeneration International. I'm the African coordinator as well as the steering committee member of Regeneration International. You can follow us on many platforms. We have lots of incredible partners who are doing this work, and today these two gentlemen represent such partners. So I guess Doug and Roland, you can just go ahead and greet the people, say a little bit about yourselves, and then we kick off our chat today. Well, it's tonight, it's 7 p.m. in Zimbabwe and Malawi.
Well, my name is Laifolo Dakishoni of Precious, as explained. I work in Malawi with the Soils, Food and Healthy Communities Organization in the northern part of the country. And we work here with several farmers. I can say about 15,000 farmers. That is in the north as well as in the central region of Malawi, in trying to improve the soils, improve the food, and improve the healthy situation of the communities. As by the name, which is Soils, Food, and Healthy Communities, in brief, this organization started with the exploratory research in the communities who work in the north, and from there, communities were worried with the high malnutrition rate in the children. And going to the deep of that, we discovered that they also mentioned that the problem was not necessarily on the malnutrition as such, but the problem was their soil. It has degraded quite a lot. So the name started from there, and we came with an approach to say, well, what if we improve the soil? What will happen? That was our question. Will it necessarily improve the food situation? If it improves the food situation, does it necessarily improve the health status of the communities which we are working with? In the end, that's where our name was born, to say soils, food, and healthy communities. So we started working with the communities in the north around 2000, and we have been spreading our work into other parts of the country, including the Central region. Briefly, maybe I should stop there.
Thank you, Doug. Yeah, we'll hear from you a little more later. Thank you so much, and for that emphasis that, well, you can improve food, but how? The biggest question was then to tackle the major source of the food, which is soil. Thank you so much for that enlightenment already. Mr. Roland? So my suspicion is that Roland is muted. He can unmute.
Okay. Yes, I won't tell you how many years I've been working in development, because then you'll know how old I am. But I've been working with green manure cover crops, which is what we call, other people call them green manures. When I first started working with them, I was in Latin America, and there we call them green manure cover crops because they also control weeds. But now we know they do a lot of other things, so even that name is obsolete. But I've been working, I've worked with green manure cover crops in about 50 developing countries, of which 23 are in Africa. So I have a fairly good idea of what's going on around Africa and what works. In fact, the last 6 years, I've been trying to find out what are the best green manure cover crop systems to use in each of 10 different countries. Because frankly, in Africa, we have a huge problem coming on, and that was true even before the coronavirus came. Soils are getting worse and worse because people no longer have enough land in order to fallow or let the forest grow. And that's the way farmers kept the soils fertile in Africa for 3,000 years, or in some places 2,000. So we have a serious problem in which the soils are getting worse and worse and worse very fast. In the last 30 years, since people had to start reducing the amount of fallowing they do, or soil organic matter levels in most of Africa have gone down from about 4% down to about 1%. And that means that even when it rains, the water can't get into the soil. According to some experiments, scientific experiments in Malawi, the amount of rain fall that can actually get into the soil used to be about 60%. Now it's between 10 and 20%. That's the main reason why we're having droughts. And so to overcome it, we have to get more organic matter in the soil. So I've been working, all across Africa, sub-Saharan Africa. And I think that's the most important thing for you to know about me.
Thank you, Roland. So that's a broad perspective of who Roland is. And in our thoughts to kickstart our conversation, I thought that it would be incredible to then have Roland just share a little bit of a PowerPoint, just to share his broad work. He's worked in many countries across different regions. So Roland, I would just welcome you to just share a little bit of the practices of green manure cover cropping and some changes that you've seen, and maybe while at that, you can also express why you think this is going to be very important for our agriculture and landscape development going forward.
Great.
So you would like us to put through your PowerPoint? Yes.
Mm-hmm.
And while we're doing that, I would like to welcome anyone with questions to please keep writing them on the chat box, because we're live on Facebook, and then we'll ask the two gentlemen the questions.
Okay, I'll go ahead and start. We need to get it on. Yeah, there we go. Okay. Oops, part of it's gone. Well, okay. Basically, the talk is about green manure cover crops, which we've been working with for about 27 years now. This is a photo from Latin America, and here, this is a farmer that's been using them for about 4 or 5 years. You can see his maize is now doing very well, much better than it used to. I mean, he used to get about 1 ton of maize per hectare. Now he's getting 3. He's showing us in his hands. In his right hand, he's got 2 large ears. In his left hand, he's got 1. That's how much he used to harvest from his maize crop from each plant, as opposed to the 2 large ones he's harvesting now, which means he's getting about 3 times as much grain as he used to off the same amount of land. You can see the green manure growing up the maize in the background, which he hasn't harvested yet. You can see the grass barrier behind him. It's a contour grass barrier that holds the soil that started to run down the hillside. In fact, you can see his son sitting on it, and there's what, 50, 60 centimeters of what looks like a terrace there, but the farmer never had to move any soil. All he did was plant the grass, and that all that 60 centimeters of soil that he's sitting on is in fact soil that started to wash down the hill and was stopped by the grass. You can see the black soil at his feet, the black soft soil. Of course, he doesn't have to plow anymore because the soil's become so soft because of all the organic matter from his green manure cover crop. And it's black and very, very fertile. So he doesn't have to plow anymore. The green manure cover crop also controls most of the weeds, so they only have to weed lightly once instead of having to weed twice like they used to. And to me, the most beautiful thing about this photo is that his 23-year-old son is still living in the village. In the vast majority of Honduras where this was taken, young children, just like in Africa, have all gone to the city slums to try and find a life there because they know their farms aren't going to produce anything anymore. But he's out on the farm because he's pretty confident that this farm is at least going to produce well for another generation. Next. Okay, I'm missing part of the Precious. I'm missing it. It's only, I'm showing only half of the.
Oh, really?
Yeah.
Okay, let's see. Okay. Sorry, everyone. We will just do it again. Okay, so how is it now?
No, I'm still seeing only half. I'm seeing the right half of everything, but the left half we don't see.
Okay. All right. Let's see. How is it now?
Still same.
Okay. All right. Maybe you can. Okay. Maybe now you can just
use this.
Let's get our technical team to help us.
Okay. Why don't you go back to the first photo, because it'll show the no, it won't show it. I'll use it the way it is. Okay. Use of the subject of this is the use of green manure cover crops to fertilize the soil and end the droughts. And it's okay. Now it's working.
Good. That's wonderful.
Okay. The cause of the droughts, as I already said, climate change is part of the problem. It's what causes the rains to come irregularly. So we get a whole lot of rain one moment, and then we don't get any rain for 2 weeks, and then it rains real heavy. But the biggest problem, the main reason our crops are suffering is that because we can't fallow anymore, because we can't let the forest grow on our soils, the soils are running out of organic matter. And that means that, as it says here, the rainwater infiltration rate has gone from 60% to only between 10 and 20%, which means that's what's really affecting our crops. Next. Okay, what can we do? The only feasible solution for increasing organic matter as much as we need to increase it in our fields of basic grains, in other words, in our large-scale fields, is green manure cover crops. Now, for vegetable gardens, we can use animal manure, we can use compost because they aren't very big. But if you want to improve the soil, your soil on a whole hectare of land, it's going to take about 20 to 30 tons of compost. And I've never in my life seen a farmer who made 20 or 30 tons of compost in 1 year. So, and I've worked with, tens of thousands of smallholder farmers. So the only feasible way of improving our soils significantly and improving the organic matter content of our soil is by using green manure cover crops. They can produce 20 to 30, sometimes even 40 tons, 30, 40, 50 tons per hectare of organic matter in our soil. And like I say, you can't do that with compost. It would be way too much work. And if a person has enough animals to get all that manure, they aren't poor anymore. I mean, that means they'd have somewhere between 10 and 15 animals, cattle. Okay, next.
Next.
Okay, this is a farmer experiment. One of the beautiful things about always teaching farmers to experiment when we do development work is that we learn a lot from their experiments too. This is the experiment that got us started with green manure cover crops, because where you see the arrows on the right, that's a row of maize that was planted the same day with the same seed as the maize, one row of sort of medium-sized maize in the center, and then the rest of the maize on the left. You can see there's a tremendous difference. They were both planted the same day. And the difference is caused by the fact that the farmer, actually, he didn't believe what we were saying about green manure cover crops, or about organic matter in general, I should say, because we weren't using green manure cover crops yet. But he didn't believe what we were saying about organic matter. So he made 16 compost heaps, piled it on the left-hand side of his field, and then left 2 rows without any. Now, the row in the center there, that's about a meter high, meter and a half, obviously stole some organic matter from the compost. But the one on the right, you can see is what, ankle high. And the only difference between those two parts of the field is that on the left, the farmer turned over the soil and put in all this compost. And on the right, he didn't. So that's what organic matter can do. And we now know, I mean, at first I didn't even believe it. I went around and asked his neighbors if he was telling us the truth. But that can happen on the vast majority of soils. The only situation in Africa where that can't work is, first of all, if they've been using way too much chemical fertilizer and the soil is now acid, or if they've been irrigating too much and the soil has become saline, lots of salt in it. But if you don't have one of those two problems, and that's a very small part of Africa, green manure cover crops will do this. And I've seen them do it even on the what are called Kalahari sands in western Zambia, which are some of the worst soils you'll see anywhere in the world. And after 3 years, we had a decent maize crop. So this will work anywhere. You just have to do it. Next. Okay, a quick definition for what we call green manure cover crops. They're any plants, including trees. We also include trees because some fertilizer trees are very good for the soil. And in fact, our work in Malawi, in southern Malawi, in that area, glycidia trees are the green manure people most like. And in 2 years, we've had over 30,000 glycidia trees planted in farmers' fields because it's just tremendously popular. It's spreading like wildfire. Anyway, there's any plants, whether they're trees, bushes, climbers, crawlers, or waterborne organisms even, that farmers use, among other reasons, to fertilize the soil, control weeds, and overcome the droughts. Next. Okay, the advantages. There are more than what we are going to see here, but anyway, usually they can triple present yields of basic grains. That means if farmers are starting out with about 1 ton per hectare of maize or less, if they're starting out with 1 ton, let's say, by the 3rd year, they should be doubling that. They should be getting 2 tons per hectare. And that's what the green manures now intercropped with them. So they're also getting some beans along with that, some high protein beans. But 3 years is about the average time, if you're doing it right, to double your yields. In about 5 or 6 years, you should be able to triple your yields and at the same time largely eliminate the droughts. Okay, these same plants can produce a large quantity of additional food rich in proteins. In other words, most of the green manures, now not all of them, but most of the green manures we use are also foods that we can eat. So and they're high in proteins. And in fact, some of them, like Lab, we can also eat the leaves, which gives us a year-round, and you can dry them and store them so that you have a year-round source of proteins, which is a tremendous benefit. And the leaves, of course, are basically free. They're just a byproduct of producing the beans and fertilizing our soil. 3, some of these green manures also reduce the hunger season or totally end it. Because like Lab, they will grow clear through the dry season once we get our soil improved a little bit. 4, they can also help reduce the labor needed to control weeds. And this, frankly, is one of the things that makes them really popular with women. When I'm introducing green manure cover crops, or our extensionists are doing it, we always ask that women be present, because the women will love the fact that they only have to weed their maize once instead of twice. And they also love the fact that if they have some glycity in their fields, they won't have to go so far for some of their firewood. So you know, there are tremendous benefits here, for especially for women. Next. They can reduce the impact of droughts by up to 80%. In other words, if they're now getting 3 tons per hectare of maize in a really bad droughty year, when other people who aren't using green manures will basically lose their crop entirely, they will still get 2.5 tons per hectare. So it's a tremendous advantage in places, which is a huge part of southern and eastern Africa. It's a huge advantage for people that are suffering from droughts. 6, they can sequester carbon in the soil long-term at a rate of up to about 5.8 tons per hectare per year. This basically is a benefit for the rest of the world. This means that we're gradually reducing, well, also for Africa, we're gradually reducing global warming. Now, you know, 1,000 farmers or even 1 million farmers in Africa is not going to make that much difference. But if we can get all of sub-Saharan Africa to use these, and that's one of the things we're hoping to be able to do, then this could make a difference. And, you know, and in the meantime, we'll be telling people in Latin America and Asia how they should be doing it. Okay, number 7, they can produce a good deal of other products. Depending on the green manure you use, none of them will produce all of these, but depending on the green manure you're using, you can get firewood, you can get medicines, you can get year-round fodder for your animals, even during the dry season. We can get Glycidia, for instance, has a rodenticide that will kill rats and mice when we're storing our crops, etc. Next. They can go a long ways toward very cheaply protecting our crops from the impact of global warming, in other words, from the droughts. 9, they can reduce overall costs by eliminating or reducing weeding labor, eliminating or reducing tillage, because after 2 or 3 years, you don't have to till your soil anymore. The green manures will make it soft and nice. So just like you know, people's fathers and grandfathers never tilled the soil after they'd grown the forest on it for 10 or 15 years, because it was so soft there was no need to. And they also can produce firewood right in farmers' fields. Next. Okay, here we can see the increase in fertility. The upper field there is the same as the lower field, except the upper field had 2 years of a green manure cover crop we call mucuna. And you can see next. You can see here closer, the same field. The lower half of this photo, the maize, you know, maybe it'll produce half a ton. The maize in the upper half will produce probably 2.5 tons. So we probably got, this woman, the farmer on the left, has probably increased her overall yields of maize by about 5 times. Next. Now, this is something I didn't even believe 10 years ago, but I do now, because I've seen it happen in about 5 different African countries, including Zambia and Mozambique. This is a field in Madagascar where you know, the farmer basically did what she always used to do, except this year she started growing a type of 9-month cowpea, which is the little green blotches you can see in the photo. The maize, nevertheless, has suffered from a severe drought, a really bad drought. You can see the leaves are all curled up, and it's not going to produce much at all, maybe half a ton or something per hectare. But, you know, it's in really bad shape. Now, if you look at the right-hand side of the photo, about the right third of the photo in the background, there's some really, really green leaves going up fairly high. Okay, that's this field. Next. This is the maize. The only difference between this maize and the previous shot is that in this field, she's already been using that 9-month cowpea for 6 years. So this is, you can see here what happens to your soil after 6 years. This obviously had to go through the same drought as the other But in this case, she's been using a green manure for 6 years, and so she's got almost total drought resistance. Go back one. Now, just to prove that, these photos were taken the same day and in fields that both had droughts, look at the clouds up in the sky. On the right, you'll see one pointy cloud on the right, and then next to it on the left, a sort of a roundish oval one. Okay, next. Next. There, you can see the two clouds. Whoops. You can see the two clouds in the left half of the photo. They're exactly the same clouds. In other words, these photos were taken in virtually the same field, just a few meters apart and a few minutes apart. And so this field went through the same drought as the other one. You can see some of the leaves right next to the vetiver grass there that are competing with the vetiver grass. They suffered a little bit from the droughts because of that grass, and you can see some curled up leaves in the center of the photo. But if you look at the left, you'll see a lot of leaves that are flat as a pancake. That means that they went through the drought, but they weren't affected by it. And that's because for 6 years, she's been improving the soil. And you can also see the soil cover. That soil cover by the cowpea is also helping to keep the soil moist. Next. Okay, some people say, well, if you keep on doing this year after year after year, your soil is going to get depleted. Well, that doesn't happen in a forest. And it's not going to happen in our fields if we're putting most of the organic matter back in the soil. These are, now most people, when they've seen pictures in textbooks and stuff like that of the nodules that fix nitrogen on the leguminous plants' roots, like cowpea and like mucuna and like gliricidia, they'll have, most of the pictures you see, they'll have very, very small little round white things spaced every inch or two along a root. Well, in fact, these are nodules also, and these nodules all came from one mucuna plant. Now, the farmers did an interesting experiment. They cleared everything else around it, so it had no competition. And this is in a field where they've been using mucuna for 8 or 10 years. So there's lots of the microbes that fix that nitrogen. There's lots of them in the soil. But these are from one single plant. In other words, we're getting levels of nitrogen that no farmer in the United States would ever put on their soils as they use chemical fertilizer. We don't have to worry about nitrogen. By the second year, our maize should be coming up very, very green and good and tall and very productive. Next. Okay, what are the disadvantages? We need to be honest about the disadvantages too. They occupy space in our fields, except that we always intercrop them, so they really aren't occupying any extra land at all. And the other thing we often do is plant them so that they grow through the summer or the dry season. Second, most of them only show visible results during the second year. In other words, we have to wait a little more than a year to start seeing results. We aren't going to see results the first year because we're just basically producing the fertilizer. We aren't applying it yet. We apply it at the beginning of the second year. So farmers do have to be a little patient. They have to wait for about a year, about 15 months in order to start seeing really significant results. 3, they can be affected by difficult growing conditions. Anything that affects our crops, like drought, like poor soils, acid soils, any of these things that affect our maize can also affect the green manure cover crops. But we do have ones, and the ones that if I were talking about different species, that'll be Dak's job today. But if I were talking about the different species we use, they all are ones that work quite well or immediately well, moderately well in even very poor soils. Next. 2 more disadvantages. In many cases, it's difficult to have green leaves available when the next season starts. And this is extremely important. One of the 2 golden rules of green manure cover crops is we need to apply green leaves when we plant our crops, not 6 months before. If we're growing, for instance, 3-month cowpeas or 4-month cowpeas, and we put the leaves on the ground, and then there's 6 months of dry season, we've lost all our nitrogen and most of our biomass before the next season. So we aren't getting hardly any impact. We need to put green leaves on the ground at the time that we're planting our new crop. And that brings up the fifth problem, which means that the organic matter has to be there, kept away from free grazing animals. In other words, these things have to sit on these have to be growing on the ground during the dry season. Now, we can do one of two things. One is grow ones that animals won't eat, like jack bean, which is very good at improving the soil and very good at growing in the worst soils you can throw at them. The jack bean will grow very well, and it will grow through the dry season, and the farmers will very rarely ever touch it. The only time I've seen animals eat it was in a very droughty year in the northern Sahel, that was in Burkina Faso. But I don't think here in southern Africa there would be anywhere farmers are growing food where the cattle are going to eat it. The other thing we can do is grow a fence, and luckily we are now using in Malawi, because we Catholic Relief Services that I used to work with in Malawi discovered a plant called the monkey thorn tree. And this makes a wonderful live fence. You plant it, and within 1 year, it will keep the cattle and the goats out, and it will last for 80 years to 100 years. And during all that time, it'll keep the cattle and the goats out. The only labor you have to do is prune it once a year, right before you plant your crops, and also keep the fires, the range fires, the bush fires away from the fence. But if you do those two things, you'll have a really nice fence for 80 to 100 years. Next. And it also provides firewood, so that even the pruning is just it's basically the work you'd have to do to get all that firewood. Okay, the golden rule of green manure cover crops. We're going to get into how to manage them. The golden rule is that their green leaves must be on the ground at the time that farmers plant their next crop. 2, farmers are presently using more than 100 different species in different parts of the world of green manure cover crops. This is, and in fact, there are over 15 million farmers that are now sustainably using them. And by that, I mean, they're still growing them. At least 100 farmers are still growing them 5 years after any outside influence has left the area. So, we have at least 15 million farmers around the world that are using green manure cover crops and have been using them for at least 5 years in the absence of any outside influence or any outside subsidies or anything like that. Okay, so there are over 100 species. Now that causes a problem because we've got to choose between them. But luckily, because of the work I've been doing the last about 6 or 8 years in some 12 countries in Africa, we've got it down to about 10 species that work really well in Africa. And so you've got to choose from these 10 species. So that's not such a big problem. Next. How am I doing for time? We still have a few minutes? Precious?
Yeah, I was going to say maybe in 5, so that maybe if we have anyone on Facebook Live who wants to ask a question, we can roll them over to you. When we ask a few more questions just to, basing on your experiences.
Okay, I'll finish in 5 minutes. That's easy. Okay, cool. Unless the green manures also produce food, we can't grow the green manures in place of farmers' food crops. In other words, we almost always in Africa, we grow the green manures intercropped with maize, sorghum, millet, or cassava. We grow them intercropped, so we are still planting all the maize we ever did, and in fact getting higher yields of maize on that land at the same time that we're improving our soils. So they don't take up any soil. The other thing we often do is grow the green manures during the dry season. And then the fourth, imitate the forest over time. Okay, now this is sort of medium to long term. But eventually what we want to do is imitate the forest, because in the forest, the forests have been around for 3 million years. They're very sustainable. They produce a tremendous amount of biomass. They never suffer from droughts, and the soil stays fertile. That's what we want to do. So gradually, as time goes, we want to add more green manures. We want to get what we call a dispersed shade growing over them. We usually use Gliricidia for that, but we can also use some native species. And so basically what we eventually want to do is have a forest which still has room and space and enough sunlight for maize to grow, or sorghum or millet. Almost all farmers, what they do is, if they're growing sorghum or millet now in Africa, as soon as they see their soil's gotten better, they switch back to maize, because maize is what they really want to eat. So usually I just talk about maize, because in 2 or 3 years, the farmers will be growing maize again. They in fact, this last time I was in Malawi, in southern Malawi, where we have a program, one of the farmers, as we were leaving the last farm, one that we visited, one of the farmers came up to our car and said, the most important thing about what's happened here, the most important thing for us. And he says, we used to have to, the last 10 years or so, we've had to eat sorghum. Now we're eating maize again. That to him was the most important thing that was happening. Of course, he was also producing more maize than his family could eat, so he was getting some income. He was starting to, which is very, very common. After about 3 years, people realize they have more maize than they can eat instead of not having enough. And they start selling it, and they realize, hold on, this maize doesn't have a decent price. We aren't making much money off of maize. So then they start looking at what other things they can grow. They have extra land and extra time, and they can now start growing vegetables or fruit trees or something that provides them a much, much better income. And this farmer was already starting to do that after just 2 years. Next. Okay. Here are 3 different crops. This was actually in Indonesia. Like I say, I've worked all over the developing world. This was in Indonesia, but here's a meal we sat down to the first day I was on the island of Sumatra. And they served us these 3 foods. One is mung bean sprouts. The second is cowpea pods, the green things there. And on the left, soybean, soybean tofu. So they were growing 3 different green manure crops in their fields, and that's what they gave us for lunch in the roadside restaurant. In other words, there's lots of green manures we can use, and as we learn more about them, farmers will start using more of them. Next. Okay, now I'll talk just very briefly about 3 different species that are very good for Africa. This is actually not in Africa; it's in southern Mexico, but it's a very, very poor farmer. The fellow in the photo is actually the farmer trainer, the lead farmer who was teaching the farmer. But you can see in this photo, there's very few plants of maize. That's because 3/4 of the plants of maize died because of drought. Nevertheless, the jack bean there is growing very, very well. The maize, there's very little of it left, but the jack bean is growing very well. So that's one thing, is this jack bean is very, very drought resistant. It also produces a tremendous amount of, in 1 hectare, this jack bean will produce as much nitrogen as 6 sacks of urea, which many of you will know is the fertilizer, the chemical fertilizer that has the most nitrogen. But jack bean will produce the equivalent of 6 sacks of fertilizer. So the idea that we're going to run out of nitrogen someday is totally mistaken. Next. Okay, here's jack bean growing among cassava. The cassava is producing 3 or 4 times what it used to, and furthermore, they only have to weed it once. They have to weed it once instead of weeding it 3 times like you usually do with this kind of cassava. They only have to weed it once. So this is a tremendously important way of reducing labor. Third, next. One of the others we use is lab. We usually can't use that very well the first year we're growing green manures because it doesn't do well in the really, really poor soils. But after we've used jack bean for 1 or 2 years, then the lab will grow very well. Here we see it 3 months into the dry season. We're 3 months into the dry season. The maize was harvested 3 months before this picture was taken. And what the farmer will do, like I say, is let it keep on growing. It's still producing lab. It's still producing beans. You can see up on the top the pods. It's still producing food, so you can continue to eat protein-rich food for 6 months, and then you cut it down and plant your maize, and you will have a wonderful maize crop. Next. And these are Gliricidia trees. Now, this is up in Mali, in the Sahel, and we were just learning how to use them. So they were planted too far apart here. In Malawi now, they plant about twice this plant population. But this is extremely popular, like I said earlier, in Malawi. It's spreading like wildfire. And what you do is, this is 2 months before the rains come. in about a month, the women will prune these trees so the crops will grow very well. You can see they're growing crops. You can see from the ridges they're growing crops right under the trees. And they will grow. In fact, they grow better with this amount of shade than they do with no shade at all. And then the Gliricidia trees will grow and have more and more leaves until the following year. And furthermore, in what they really love in Mali is that these leaves are fodder for their animals. And you can see right now they have no fodder on the ground. The only fodder their animals are getting right now are the leaves from the Gliricidia trees. And that's keeping their animals alive. Before they had the Gliricidia trees, they would lose, in a bad year like this one, they would lose half to a third of their animals. Now they don't. That doesn't happen anymore. Next. I think that's the last one. Oh, I won't go into this. Okay, so we're finished. Thank you very much.
Thank you, Roland. Yeah, that was quite a lot, and you managed to crunch it quite well. And on our online guests, please, if you have questions for Roland, just keep typing them. I see Noah Simpija is in Uganda, a permaculture project. He would like to connect and get some materials if there are things that they can learn and probably implement in their permaculture project in Uganda. I also had just a small question for you, Roland, in terms of when you came into these spaces to train, you probably came through partners, right? But then what were the normal routines of agriculture that had taken roots in these spaces?
Okay. Well, pretty much all over Africa, the easy answer to the question about what farmers grow now is pretty much maize, unless their soil's gotten so bad and the droughts are so bad that they have to switch to sorghum or millet or even cassava. A very interesting thing that I think farmers ought to be aware of is that along the coast of Africa, there are often a lot more people. So in Mozambique, you have a higher population density than you do in most of southern and eastern Africa. Now, what that's meant is that in Mozambique, they have less land. So they had to start reducing their fallowing in the 1950s and 60s instead of the 1980s. That means that their soil is far, far worse. It's had more time to get bad, to lose its organic matter. They used to eat maize, then they went to sorghum, then they went to millet. Now, at least in northern and southern Mozambique, not so much in the center where the river is, where the Zambezi River is, but in the north and the south, farmers are basically living on nothing but cassava roots. Cassava roots, as many of you probably know, are totally lack nutritive value, almost. Okay? Which means that in southern and northern Mozambique, stunting, which is a sign of severe malnutrition and keeps children from having the intelligence, the natural intelligence, and the natural physical abilities that children who've eaten well have. Stunting is now affecting 70 to 80% of all the rural children in Mozambique. That means we're going to have a whole generation of children that are not as smart and not as physically well developed as we should. Okay? That puts Mozambique among the 3 worst countries in the entire world in terms of levels of malnutrition. Okay? Now, that's the future we're looking at in Africa if we don't start using green manure cover crops. That's what we're looking at. That's why I came to Africa. 10 years ago, I realized that this situation was going to just get worse and worse, that it was basically a problem of soil fertility and organic matter. So I came to Africa. I'd worked in Latin America for 30 years. I came to Africa because I just felt I had to do something about this. And I wrote several predictions about a coming African famine, and everything I wrote, pretty much everything I predicted is coming true. The number of people in Africa in the last 10 years, just in 10 years, in 1 decade, that are dependent on food aid have gone from 10 million back in 2010 to very close to 50 million as we speak. Okay? About 50 million people now depend on food aid, and the World Food Program is running out of food. Okay? And I know that because in southern Mozambique, where I was working last year for several weeks, people who hadn't gotten a decent harvest in 4 years because of droughts were getting food aid. But when the cyclone came along and affected most of a big portion of Mozambique, the World Food Aid had to stop giving these people food who hadn't had a decent harvest in 4 years in order to be able to feed the people and help the people that were affected by the cyclone. I mean, they're out of food. They don't have much food anymore. People that think, oh, well, you know, we've gotten food aid for the last 4 or 5 years or 6 or 7 years, so we're okay. We won't worry about it. Somebody will come and give us food. You got another thing coming. You know, that's not going to be the case in the future. And the numbers of people who are hungry are going to keep going up higher and higher and higher until we do something about it. So anyway, now your other question was what?
No, that's all right, Roland. And I think we're just going to dive into a bit of what Doug has to share. Thank you so much for sharing. And obviously, Roland continues to run classes, even during the COVID-19 lockdowns, when people are not gathering physically. He's very active online, and he's here to share all this wisdom and knowledge with us. I think we can connect with Roland and keep learning. So he's obviously worked with a lot of partners in Africa, and Dakishoni is one of them. So we just call him Dak. So feel free to call him that. Let's learn from the example that Dak has to share with us, and maybe connect with him and learn. They've done a lot of research work and community mobilization work in Malawi there. So Dak, you're welcome. You can take the platform. Share as much as you can, and probably start at, how important is the work that you've been doing right now during the COVID-19 in Malawi. You can share with us that.
Thank you, Precious, and everyone out there watching us and listening to our presentations. As Precious says, I work with the Soils, Food, and Healthy Communities Organization, which is a non-profit organization in the northern part of Malawi, but we also work in the central part of Malawi. We have been working with the communities in these 2 regions of the country from 2000. And the way we came up with our work was through working with the community, trying to find out their problems, and in them they taught us about the child malnutrition. But from there, we went deeper into discussions with them, the community dialogue and community discussion, trying to find their solutions. But in the end, it came out that it was the soils which were degraded, and it's when we started with the intervention of bringing different legumes into their cropping systems. And the systems we started with the also the legumes, the experiments which we're doing with them. We started with the PP, soybean, nut, brought other agroforestry species like Tephrosia, Ogeri, Acacia albida into the system. And from there, we worked with them, going through lots of other experiments and other approaches with them. And our big question was, if we need to improve the soils, we need to really give them the food which they require. And what do we need to do in order to find food for the communities and the communities improve their health status. This was our challenge. This was our with them, and in so doing, worked with these legumes, and we didn't really introduce green manure to them or the cover crop them, but the practices which we brought to them, that's what they themselves realized that what we're trying to teach them was the green manure. Just because the practices we had to ask them to incorporate to the crop rate in the end of their harvest season. And in that regard, we came up with that approach in trying to build their sustainable and healthy, equitable communities around us. All this was through farmer-led participatory research and using indigenous knowledge which they have been practicing before. As I said, we are working with our main office in the northern part of the country, and but also work in the central part in Denza. But the northern part where we started our work, we are lies in the mid-altitude and subtropical ecosystems, and the sandy loam is the main type of soils which were in, and the cropping systems, the mixed practice systems. All these have really helped quite a lot in the approach of our work, and in the end, the green manure and cover crops, as Roland has explained on the benefits, farmers came up with their own evaluation and how they're benefiting from it. One of them was the soil cover, that this reduces the moisture evaporation, and the crops grown under the cover crop were growing faster than those not under the cover crops during the drought or water stressed periods. As you explained, they brought human food, mostly the edible legumes, and the organic matter which is incorporated in the soil also build the soil health. All legumes which were using the nitrogen fixing, which they, as Roland showed, they could notice where there was legume intercropped, they were growing the following year, they had better yields than the others where they did not put any green manure or the cover crop. Yeah, animals also find something in there to eat and to graze on as some of the benefits. Yes, maybe to just explain a bit on the systems which we are using. We are using double-up legume system, and in some cases we're using the cereal legume intercropping. Just because on the double-up legume system, we plant two legumes in the same field or in the same ridge. For most farmers in the Malawi use ridges. So as you see on the picture, the taller plant is the pigeon pea, and the lower one is the groundnut. So the pigeon pea is late maturing, while the groundnut is early maturing. So when they harvest the groundnut, they bury the crop residue in the field where the pigeon pea is still standing. And when the pigeon pea gets harvested in the later in the year, all the leaves, the biomass is left also on the ground. And before rainy season and before planting, the pigeon pea is ratooned, that is, it is cut maybe 30 to 40 centimeters from the ground, and is laid down on the furrow, and is also buried for the next growing season. That gives the pigeon pea standing for another year. and the maize or the any cereal is planted in them again, and that makes the following year to have a cereal and legume system. I hope you'll be able to see it on the corner there on the right hand side. That's the ratoon pigeon pea growing together with the maize in there. This is the second year of the growing season, and this is a year when the farmers would see the actual benefit of the cover crop or the legume effects, because they're testing it by using the maize or the cereal. They differentiate the area where there was no cereal incorporated, and the one where the cereal had the legumes in. So that's how the farmers were able to evaluate these systems. The main reason why we are doing all this work is looking at feeding the soil to feed the crops. Take care of the soil so that the soil should should produce food for the crops, which will be the food for the humans as well. So yes, all the work has been around this idea: how do we feed the soil so that the soil can feed our crops? With this kind of work in this time of the COVID-19 pandemic has been so significant in the way that it is giving us nutritious foods, legumes, as well as the cereal yields have also improved. So there's like double effects, double benefits in what we are doing. If you see on the graph there, we're showing the results which we had done our research in 2010 and published these results. You see that the maize and fertilizer yields and the farrow, the soya, which this is the fields whereby there was soya legume, then we planted maize the following year. Where there was groundnuts, and we planted maize the following year. Where there was pigeon pea and groundnut, we planted maize the following year. And we compared the yields. You see that the mucuna and the pigeon pea and groundnuts intercrop, the double upper legume system, had more or less the same yields, are very high, the highest of them all, followed by groundnut. But when you look at the fertilized maize, which is with the chemical fertilizer, was quite low, showing that the legume or the cover crops had additional effects on the soils, which improved the yields of the maize, and at the same time they had the benefit of an additional food on their plate. This helped to get more nutritious food as they grow these cereals. Unlike on the maize and fertilize only, they use a lot on maize, but at the same time they don't have much diversity in their diets. Well, with the working with the legumes in our intercrops and in our as cover crops, there are also some challenges. As Roland has said, they have to be left there by the name to cover crops, to cover the fields, cover the soil until next growing season. But because farmers use integrated farming, whereby there are animals, livestock with them, so there's like a trade-off effects in the whole thing. The livestock graze on the cover crops most of the time, if left unfenced. He mentioned about fencing in the other project in the southern part of Malawi. It's a new thinking, it's a new way of protecting the cover crops. And in the north, this hasn't come up yet because of other the other challenges in terms of finding the proper fencing material. We have also the effects of the pests. As you see on the pictures, that beetle is quite devastating. Beetle on the pigeon pea, beetle on the jack beans. You find them enjoying the fruits, and when they eat the fruits, whatever they do to the fruits, we're yet to study how they're affecting the fruit, but it doesn't pod after that. Even if the flowers are left there, but once they're visited by these beetles, they will never pod. The other one, which I mentioned, Tephrosia, we have been using Tephrosia, but the adoption rate has been very low because the farmers wanted some legumes which they can eat, while Tephrosia is not edible. The same with the velvet beans, Mukuna. You saw the previous graph that the effect on the yields on maize was wonderful. But the challenge was they don't eat the seed. And for it to have that effect, we had to bury the legumes at the flowering stage. That was the point when we researched it was the most effective as a green manure. And we buried this year and leave it in the soil for the next growing season. That's what that effect was brought in. And culturally, Mukuna also has stigma because it killed, it's poisonous in a way. It needs to be prepared properly, thoroughly, and for a longer time, and clean the poison. So, and previous in the years, our ancestors in the north here, they were killed by those who were fighting in the area. It was set as a trap for the others. So they left and cooked, probably cooked the mukuna for the others who were not used to the mukuna, and they found that the whole food is here. And when they ate, they all perished. So that stigma is still around our communities in this part of the country. So yeah, well, the communities themselves have tried to come up with some solutions to some of these challenges by instituting bylaws and penalties for the livestock to graze in the fields. And we, on the pests, we are still learning from others and other stakeholders in our network how they're dealing with these pests and beetles. Some told us that if we put the black, not the black, but the green bucket in the field with water in it, it will attract them and to trap, they'll fall into the water and they'll be trapped in there. And we have to take them and maybe use the water for spraying the legumes as well, or which they were soaked in. So we are yet to try that, and that's what we're trying to do at our learning center and the research center, to experiment with what we're being taught as of now, so that we save the cover crop and as well the legume for people to enjoy. Another way forward is, as Roland has said, that there are so many species to use, and we have to find out which ones are best suitable for our communities and which ones are really going to grow well in our conditions and the climatic conditions. The farmers expressed their interest to use only those which they have multiple usage and multiple benefits in terms of food, to diversify their food and the diets, also, and the cover crop effect, as well as the nitrogen fixing effects as well. Yeah, we would love to learn from others in the network how they're getting on with all these cover crop messages, and how we can spread the messages together. Yes, and how we can move forward. Prefer to answer your question, Precious, on how this work has an effect or an impact on the pandemic situation as we are in at the moment. Yes, it is a challenging time, but this work is helping the farmers now to have crops diversified and their diet diversified, because now they have several foods on their plate. Previously, they could only have maybe one or two food on their plates, but now they have at least 3 to 4 foods on their table, including the legumes. Yes, I stop there.
Thank you, Doug.
I'd like to add that in Central America, where people have been growing green manures some of them have been growing green manures for 8 or 10 years. I just got a letter from a friend down there. I haven't been there for 6 or 8 years, but I got a letter from a friend down there who says that an awful lot of people who had gone to the city, gone to live in the slums, are now returning to the villages because they realize that with the pandemic, first of all, it's much more dangerous in the cities because there's more people that have it. And secondly, out in the villages now, the farmers have all sorts of food because they're growing the green manures and they're growing the maize. And they also are growing cash crops and other things like that because they have more maize than they can eat. And so they're much better off being in the villages than they are in the cities. So people are moving from the cities back to the villages where they used to live in order to have a better life and be safer from COVID.
Thanks, Roland. Actually, I think with urban to rural, I think that's what we've also seen here in Southern Africa. I'm sure it's the same in Malawi, same in Zimbabwe. There's lots of pressure now in the rural communities because most people have left the cities due to loss of jobs and the safety and the importance of just where the food is in terms of in the communities. And I'm sure communities in the US also is the same. It's this is going to be really game changing in terms of food production and things like that. But I wanted to just check with you, Doug, in terms of what has been some of your pressing sort of barricades or blockers of the work going ahead. You're in competition with synthetic fertilizers, sometimes big agriculture, NGOs. How have those affected your work, and how have you seen the adoption of farmers of green manure cover crops as natural remedies?
Yeah, Precious, is true because there are several players in the system, especially the Ministry of Agriculture and others, NGO as well, who promotes synthetic fertilizers. But they have also come back to us and said, what you are doing is the proper way to do things. Because with the experimental trials we have planted in the communities, they have seen that we are growing be it the maize or the sorghum or the finger millet without any chemical fertilizer, but the yields were even better than theirs. And in terms of the drought situation, they would see that their maize was wilting, where our farmers who are practicing, the maize was steady. Even if 1 week drought, their maize could be heavily affected, while the maize under the cover crop or in the intercrop could be as nice as ever. And that even the agri-techs, the agriculture extension officers, have come in the open to say, I think we just have to increase this technology to spread, to be part of our teachings. But yes, it has been a challenge in the sense that there's some input subsidies, whereby in the package mostly is the chemical fertilizers and the less legumes in the package. And that is also really affecting, because now the farmer says, well, this is a quick solution to me. As Roland has said, the benefit are seen on the following year. It's not in the very first year. So the following year, for some farmers, they find it a challenge to wait and see the benefit the following year. But those who are practicing, they have even showed that their yields have really increased. As the graph I showed you, and that's what the farmers who are practicing have really indicated. So yes, challenges are there just because of the farm input subsidies, which are there, and agri-tech technology. And again, the research institution or the research agents funders, they're not really funding our approach in terms of research. There is a small, or I can say underfunding on this type of work. You find that when they want to release a new type of chemical, a new type of fertilizer, there's heavy funding through the universities or other research institutions for billions of dollars just to do that. And usually such type of work, such type of research go through these big institutions or the universities, and even they try to go through the agriculture extension officers, and that their presence is like big in the community, and which shadows our approaches. Thank you.
Thank you so much, Doug. And yeah, go ahead, Roland.
I'd like to very briefly just say something that Doc has said is really, really important, and that is when they're using pigeon pea, they are retuning it. In other words, they're cutting it off the stem right before the maize. Actually, we do it about 10 days after the maize has been planted, the next crop of maize. And that's really important for one thing that a lot of people don't even think of, and that means that the second, third, and fourth year of the pigeon pea, because it grows for about 4 years, the second, third, and fourth year, it has a good root system already. It's got a year or 2 or 3 years of root system, which means it's as drought resistant as the forest is. So that, the first year, if you have a really, really bad drought, you might lose a lot of your pigeon peas. But the second, third, and fourth year, no matter how bad the drought is, you're going to get a good crop of pigeon peas, and that's high protein food. So you don't have to worry about not having any food if there's a bad drought. You will always have pigeon peas. In fact, some people in southern Malawi are now growing the pigeon pea. They'll plant a quarter of their field one year, and then the next year they'll plant the other quarter and retune the first year. And the third year they plant another quarter of their field and with the pigeon pea, along with maize, and as they're doing the doubled up legume system with maize and ground nuts or maize and soy. And that means that because they're rotating it like that, that means that any given year, 3/4 of their field is totally drought resistant in terms of the pigeon pea, which, that's a wonderful thing for people that have, lost their entire crop from the droughts in past years.
Thanks, Roland. So really, when we zoom back into the work that Doug has just defined, it seems to me that it will be very important to sort of think of how we can support this work come alive. Because obviously, you cannot argue with the results of trial plots. You cannot argue with results of maize that is 3 times more than synthetic fertilizer plots. So we need that kind of work to to be, to be enlarged in terms of its voice, and many people and many governments and our policymakers to be exposed to it. But I'm also aware that we are in a setup where really, in terms of funding, I don't know about in Malawi, but in most parts of Africa, you would want to see how can the world support this work that you are doing, Doug, the work that you are doing, Roland.
Well, one thing is that what we have to do is find systems that really expand spontaneously. In other words, farmers teach other farmers, or even if they don't teach them, the other farmers see those gliricidia trees out there, and you can see gliricidia trees from 2 miles away, and the farmers will go. The farmers for 2 miles around where you have some will. What's that farmer doing? He's growing trees in his field. That's terrible. The trees cause lots of shade, and that affects your maize. But then they see that the people that are doing that are also getting a good maize crop. And, even if the farmer doesn't bother to teach them, they're going to go and try and harvest some gliricidia seed and do the same thing in their own fields. The technology sort of grows legs and walks by itself. And this is what we need to do. In our program in southern Mozambique, actually, we're following up on a Catholic Relief Services program that was there, and their funds were cut off prematurely, so the program ended before they really wanted to. And so there's now 2 of the people that worked in the CRS program have now set up their own NGO called Imagine Africa, and they have 40 lead farmers that are spreading the technology that were trained by Catholic Relief Services. And now this year, the gliricidia is so popular that another 30 farmers have said they want to be lead farmers and teach more communities. So, the program in its second year has only spent, I think they've only spent about $25,000 because almost all the training is being done by lead farmers. And they're doing it for free because they believe so strongly in what they're seeing in their fields. And so, I think that's what we need to do is we need to have it spread spontaneously from farmer to farmer. And we also, if possible, need to have technologies that are highly visible, and most green manures are, so that other farmers will copy it even if nobody comes and teaches them.
Thank you, Roland. Doug, anything on how this work, the world can connect and support this work, especially in the face of what we're going through right now? I mean, it's even brave to see that there's still people on the ground working currently with what's going on in the world.
Yeah, I think it's very important that others support us in this particular work. And most of this work, for us to spread across, we work with the farmer research team. These are the farmer lead farmers, in other term. But we believe in the farmer-to-farmer extension learning, and whereby we build the capacity in the farmers, and the farmers are the ones who go back and in their communities and to train their fellow farmers by doing, as well as by growing, as well as in practical. And we use 2 approaches in the trainings. That is through discussions, through practical, through songs and theater, and we have even developed a curriculum which is farmer-friendly, usable. But yes, we need support for us to spread the work by training more farmer research team members and to support their work. The good part is that eager and able to learn new things and to experiment things and to do it. They're so enthusiastic. Thank you.
Thank you, Doug. And for those who may be interested, the Soils and Food for Healthy Communities organizations, we just call them SFHC. SFHC. Try and say that again. They were winners of the Lush Spring Prize Award for Regeneration, which is an award for regeneration of land and communities and economies. So really their work, like Doug has just said, that maybe they're just in a bit of a dark passage now due to the COVID-19 affecting many things, I mean, including big foundations that have been funding. So maybe you can get in touch with Doug, and through our website at Regeneration International, you can get to learn more about what they're doing. They have incredible researches and evidence-based information that this actually works, and it's broad, their activities that they're doing. So really, I'll just invite anyone to just take a free tour. And this is like 8 p.m. and our networks are usually really terrible, but it's great that we pulled it to this far. And I'm so grateful to Doug and Roland. They shared honestly from their hearts and such generous wisdom. Obviously, this is such an opportune time to share this kind of information. It can be inspiring. I don't know in Malawi or California, but everyone in my sphere here, everyone's a gardener now, whether you're in the city or in the rural areas. So this becomes information that is available for free, that you can actually intercrop, have green living manures, improve your soils. You don't have to add any expensive additives, be it expensive to the biology of your soil or to your pocket. You have everything in your disposal that is natural and absolutely long lasting. So you realize, actually there's a story that I really liked that you did, Doug, that some of the green manures that you then can recommend to the community. It's funny how our cultural backgrounds are so interlinked with what we eat and what we believe we want in our fields, in our cattle, in around us. So you can imagine a historical, is it Mukuna? A historical disaster that happened with a tribe that was prepped. They cooked and they ate a poisonous Mukuna. And it will take a lot for you to introduce that manure back into that community. And maybe sometimes you have to find an alternative, or over time people can ease into the idea, and some will still not eat it because culturally their heroes were slain by the same. So it's amazing how you can never live out. In regeneration, it's social, cultural, political, economic, and biological. They all got together to have that relevance. I don't know if there are any questions from our viewers. We are really close to just sign off. We were aiming at 1 hour, 20 minutes. We didn't do badly. We're like 1 hour, 23 minutes. I would like to thank everyone in our audience. Please connect to Roland, connect with Doug, Laifolo, connect with me, go to the Regeneration International website to learn more. And if you work in this kind of spheres, we are there to bring connections as RI. That's where you plug in and become partners as well, so that we all become a big resource pool and we can encourage one another, especially during these hard times, to keep going. Otherwise, thank you so much, Siyabonga. Zikomo, that's what they would say in Malawi. Roland has something to say.
Yeah, I just wanted to leave my email address with people so that they can write me. It's rbunchw, all together, lowercase, small letters, and then at gmail.com. And we do have all sorts of materials about green manure cover crops, and even a book. I've written a book on green manure cover crops. So there's all sorts of materials.
So you said rbunchw at gmail.com.
At gmail.com, yes.
Okay. And then I think our tag at Regeneration International connected Dakishoni's website. And if people need information, they can always contact us. So that's Roland's contact. Thank you so much, everyone. And thank you to our team that supported us with the tag. We had all sorts of struggles, but here we are, we've done it. Thank you, gentlemen. Thank you,
Thank
everyone.
you.
Okay, cheers.
Cheers.
Cheers. Bye-bye.
Bye.